This is my Cryptographic Foundation RSA assignment screencast. To start off, the user enters in two integers, a and b, a being the larger of the two. To check this, I put in an if statement. If a is greater than b, proceed with this method, otherwise print out this line. If a is greater than b, the answer that we want returned is a getting the mod inverse of a and b. If the answer is less than 0, you have to add on the initial value of a to get the answer, and then output that. Down here we look at the check prime function. To start off, a is set to phi, which would be the letter A that the user entered. B is set to E, which is the smaller value that the user entered. Last x is equal to 1 and last y is equal to 0. This means that there is 1 phi or 1 a and 0 b's. Int x is equal to 0 and int y is equal to 1, which means there's 0 a's and 1 y. Int or is equal to a. This is a holder for this value. While or is not equal to 1, int q is getting the whole number divisible of a divided by b. Or is getting the remainder for a divided by a modulo b. A is equal to b and b is equal to or. This means that a takes the value that was in b and b takes the value that was in or. Int temp x is a placeholder for the value x while x changes. X is equal to last x minus p times x, which is the whole number, which is q, times x, which is 0. Last x is equal to temp x. This changes the value that was in temp x to last x. Int temp y is a storage place for the value y before it changes. Y is equal to last y minus q times y. Q being the whole number and y being 1. Last y gets the value that was in temp y. This method will return the mod inverse of the two numbers. Now I will show this method working. To start off, I will use the values 17 as the larger integer and 10 as the smaller integer. The return value of this should be 12, which it is. Next, I will try using 19 as the large number and 3 as the small number. This should return the value 13, which it does. Next, I will try it with a larger number. The two numbers I will use for this is 4032 and 2971. 432 being the larger integer and 2971 being the smaller integer. This should return the value 19, which it does. Next, I will try two numbers that I know aren't co-prime. I will use the larger number being 45 and the smaller number being 6. This will return an error because it is not possible, because or never reaches 1, which it does. And again, I will try with another two numbers I know are not co-prime, which is 24 being the large number, 4 being the small number, which will also return an error. Next we will go on to part 2. For part 2, unfortunately, we were only able to get it working for numbers. To start off this, we defined all of the numbers that we needed and give them names. To start off, we asked the user to enter a prime number p and a second prime number q. Then we calculated n, which is p multiplied by q. After that, we calculated big integer, which is p subtract the big integer value minus 1. Phi n is equal to phi n, which we calculate above to be p subtract big integer value of 1, and multiplied it by q subtract big integer value of 1. This gives us phi. Now we have phi n, p and q. Then we ask the user to enter a value e, which is co-prime to phi of n. We also ask the user to enter a value d, which is equal to d times e is equal to 1 in the world of phi of n. The values n and e form a public key and n and d form a private key. We then declared m and c, m being the message we wanted to encrypt, which we passed in by the user, and c, which is the encrypted number that the system puts out. M is then equal to the decrypted value, which should be equal to what the user entered. I will now show part 2 working for numbers. The first prime number I will enter is 23, the second prime number I will enter is 41, the E I select is 19, and that shows the private key is 139 and 943, and the public key is 19 and 943. The message that I want to encrypt is the number 25. This will return the encrypted number is 187 and will return the number 25. Secondly, I will try it for another number, which will be the second value I want to encrypt will be using the same numbers as P and Q and E, which is displayed on the screen. The number I want to encrypt is 135. It'll encrypt to 17 and return the number 135. Lastly, I want to show that this system is not capable of handling very large numbers. It is unable to handle this number and as you'll see now in a second, it won't return the same answer. It encrypts to 473 but only returns 423, so it is not returning the same as what was put in. Thank you and goodbye.